just in case you missed the review day leading into the quiz here in Unit 2, Chapter 2, whatever you want to call it. Or if you just want to do some extra cramming and kind of go over this again with the help of my awesome voice and words. Here we go, the video for the review for the Chapter 2 quiz. This should cover sections 2.1 through 2.5. Pretty sure. Here we go. Let me get the pen. So the first couple of problems are all about doing operations that involve numbers in scientific notation. And I want you to notice, I don't know if this is going to actually be a real issue, depending on how the classes go. Like this, like it's not like you're not going to do this anyway, but make sure to keep your answers in scientific notation. So here's how we do this. When we're multiplying a couple of numbers in scientific notation, all you really have to do is multiply the 2 and the 3 together, those regular numbers, okay? The 2 times the 3, and that will make 6. And then you're also going to then multiply the 10 to the 3rd and the 10 to the 7th together. And to do that, since it's like the same base of 10, you can add the powers. So the regular numbers, you just multiply, and then the exponents on the 10s, you add. So 3 plus 7 is 10. And this is in true scientific notation because this 6 is an acceptable number as it's between 1 and 10. And it's always going to work out nice like this. It's not like I'm going to give you a 2 here and like a 9 here, and that would have made 18, which wouldn't have been an okay number for your final answer. You would have had to adjust things, and you would have needed to rewrite the 18 as like a 1.8. Essentially, you'd have to move the decimal place and then adjust things. But again, you can almost forget I said that just now, because I think you're always just going to get a nice number that is A-okay for final scientific notation, like the 6 here. Now, when you're dividing, it's very similar. You take the 8 and the 1, and you're just going to divide those straight up. 8 divided by 1 is, you guessed it, 8. And then as far as the 10 to the 12th and the 10 to the 7th, you can divide those, and since it's the same base of 10, what can you do with these powers of 12 and 7? You can subtract them. So 12 minus 7 is 5. So that's how you do it. Divide the regular numbers, subtract the powers on the 10s. Same old stuff right here. This is multiplying this number times this number. So 4 times 2 gets you 8. And then when you add the powers, maybe even on your calculator, negative 8 plus 3 is negative 5. And that would be your final answer. Over here, 4 divided by 2, you just do that regularly and get 2. And then you subtract the powers carefully, because notice here how this becomes 3 minus a negative 2. Again, that's 3 minus a negative 2. Minus minus 2, which really means you're adding the 2 to the 3. Again, your calculator will pretty much do this thinking for you if necessary. But the final answer is 5. 3 minus a negative 2 is 5. Final answer. Okay, in number 5, 6, and 7, numbers 5, 6, and 7, they want you to do x minus y, but please, please, please pay attention to directions. They're telling you that x equals 8 actually, and y equals 4 actually, so x minus y is really 8 minus 4 when you substitute in the 8 for the x and the 4 for the y. In other words, plugging them in. And so 8 minus 4 is, oh gosh, I don't know, 4. Same thing in number 6. We're just going to do y minus x. So we're going to be doing 4 minus 8, which is different. You get negative 4 for a final answer. And then xy, you should know. This is a very simple thing. You should know that xy means x times y, or 8 times 4, since 8 is x and y, 4 is y. And of course, that's 32. So this is multiplication here, people. Numbers 8 and 9, at least in 2018, and probably in every other year I do this quiz in this chapter, I kind of skip over this material. You know, like use your thumb and use your pinky finger. So just pretty much can skip these things for me. But you know, I guess if we were going to do this, you know, you would use like the last bone in your thumb, like between your thumb tip and your first knuckle there, or your only knuckle, or maybe not your only knuckle, but you know what I mean. Like that last half of your thumb, that would be like an inch, and you could just use your thumb. And then a centimeter is like the width of your pinky. Anyway. Skip. So now we're going to start solving for x. And you're supposed to show all your work. And so here, the first thing you would do is, just to kind of run through the full, like the full process and all the steps you might do in order from first priority to last priority, from there's no parentheses to clear. If there were parentheses to clear, you would do that first with the distributive property. But that step, which you always do first, doesn't apply to number 10. Maybe the next thing would be to check if there was any like terms that were already on the left side together, or they were already on the right side. So in other words, you would look for like terms already on the same side. That does not apply here. It doesn't look like, we can just get right into working the equation in order to get x alone on one side. So the x is over here on the left side. Looks like we also have this minus 4 over here and this 3 being multiplied to the x. Those things have to go. We want to get x alone. We want to get rid of the 3, and we want to get rid of the minus 4. So which one do we do first? Because it matters. Because it matters. And so what we're going to do first is undo this minusing 4. The opposite of subtracting 4 is adding 4. So you're going to add 4 to both sides to make this minus 4 go away. And so that leaves 3x by itself over here, and it makes the right side into 15. Now the next thing we're going to do is take care of this times 3, this 3x. What's the opposite of multiplication? What's going to make this 3 go away? Well, by dividing by 3. And when we divide by 3, that undoes the 3 there. And it leaves x by itself over here, and 15 divided by 3 is 5. Remember, whatever you do to one side of an equation, you have to do to the other side to keep the equation balanced, which means basically to keep the left side and the right side equal. Number 11. Same kind of process. I'm not going to repeat all that stuff, but we're gonna get rid of this plus 7 first by subtracting 7, so that cancels these out, and you're left with x over 3. 9 minus 7 is 2 on the right side over here. And then the way we undo division by 3, because this says x divided by 3. What's the opposite of dividing by 3? Multiplying by 3. And that's going to cancel out the 3 there. And you'll be left with x all alone. And once x is all alone, you're done. Over here, the 2 times 3 equals 6. Number 12, very, very similar. We're going to subtract 3 from both sides to get to here. And then we're going to divide by 7 on both sides to get x all the way by itself in that order again. Not to be a broken record, but you do this first, and then you divide both sides by 7 in that order. And I'm going to assume that for my final answer, instead of saying 2 equals x, I think most people prefer to be like x equals 2 and have the variable on the left side instead of the right side. So you can do that at the end. Change 2 equals x to just x equals 2, whatever. Number 13, nothing really new here. We're going to add 9 to both sides first, and then we're going to multiply both sides by 5 in order to get x all by itself, and you end up with 50. Number 14, man, these are all very similar, aren't they? What are we going to do first in number 14? We're going to subtract 5 from both sides to get rid of that, and so we start to get x by itself. We have a negative 7x remaining over here, and negative 16 minus 5 is negative 21, people. If you're going to do this in your head, make sure you are 1,000% sure. If not, you might want to check your calculator anyway, even if you're pretty sure. Because negative 16 minus 5 is negative 21. And now, hey, okay, at least this is a little different. We're not just going to divide both sides by 7. We need to divide both sides by negative 7. That's a negative 7 times x. So whatever is being multiplied to the x, this is a negative 7. So we divide both sides by negative 7. So that gets x all by itself. And then negative 21 divided by negative 7 is positive 3. Okay, number 15, there's like a little bit of a curveball, I guess. In number 15, we have the x over here. We have to get rid of this 4 and this 5, or it's basically a minus 5. So what do we do first? Well, what we do first is get rid of this separate term, this 4 that's separate. We're going to get rid of this 4, and then we're going to get rid of the 5. That's like right on the x, right with the x. Because this says like negative 5 times 5, or times x, negative 5 times x. So we're going to get rid of this 4 first. Now, I know you see a negative right here, but people, that negative is not with the 4. That negative is with the 5, you know. This 4 is a positive 4. So how do you get rid of a separate positive 4 term? You have to subtract 4 from both sides. You know, make sure you subtract 4 from the right side, and then you also subtract 4 from the left side. And so this will cancel out the 4 from over there. 19 minus 4 is 15, and what's left over on the right side is a negative 5x. So the negative is still here, and now what we're going to have to do to get x fully by itself is divide both sides by a negative 5, and over here we get 15 divided by negative 5 is negative 3, and x is alone, and just like the other problem a minute ago, instead of writing negative 3 equals x, which, by the way, this is fine. It's not like this is a wrong final answer. It's just most people like to say x equals negative 3 instead of negative 3 equals x. Silly. Number 16 is a word problem. A bike rental shop charges $10 plus $6 an hour for renting a bike. I think this is just like our notes. Problem. If Kendall paid $28 to rent a bike, how many hours did she pay to have the bike checked out? Well, people, yeah, I didn't think so. I just wanted to, because I probably have to, so, I know, here's what sorry, getting back to what I was saying. So, I'm sure a lot of you, you who's listening, maybe you can just work this backwards in your head because of kind of common sense. $28 total, factoring in how it was $6 an hour plus like a $10 charge no matter what. And then work backwards to figure out how many hours. But we're going to actually write an equation with a variable in it that we're going to solve. And do the same math anyway that you would do without writing an equation. But anyway, so first we need to kind of name an equation, name a variable. Name a variable. And usually, people, the variable is what you don't know. And I guess even more specific, our variable is usually what they're asking you to find. How many hours? The variable is usually going to represent that, the unknown thing that they want you to find for the final answer. So we're going to use H for number of hours. So that's what our variable is going to fill in for, number of hours. And so writing out an equation with an equal sign and everything that involves this variable H and the number 28 and 10 and 6, that's what the equation is. Or something equivalent, you know what I mean? But if we do the 6 times this unknown number of hours, and then we add 10, it's supposed to equal 28 for Kendall. And so this is the equation that describes the scenario. And then we just solve for H by subtracting 10 from both sides, and then dividing both sides by 6, and that gets us a final answer of 3 hours. An answer you probably could have come up with without technically writing an equation and solving it, you know what I mean? But, anywho. Ooh, a bonus question. Thanks, Mrs. Clute. Here we go. Just kind of a fancier, I dare say that you should totally be able to solve this and get the bonus points. The first thing you would have to do is distribute to clear the parentheses. Again, you don't start adding things to both sides or dividing both sides by stuff until you, this would be the first priority, is clearing parentheses with the distributive property. And so when you distribute the 8 and distribute the 5, you get 8x plus 16, and then you get plus 5x minus 20. The minus 15x comes down, equal sign comes down, negative 8 minus 4 comes down. I wouldn't blame you if you just combined those in your first step, but looks like I'm going to do that here, where I look for all like terms that are already on the same side together to combine. So yes, this negative 8 minus 4 becomes negative 12. But over here we have 8x, 5x, and negative 15x that will all combine together to be negative 2x. Look at this use of color. And over on the left side we have a plus 16 and a minus 20 that combine to be minus 4. And so I find myself here, and then where do I go from here? Well, now I just do whatever it takes to get x alone on one side. And so I'm going to add 4 to both sides, and that'll leave negative 2x over here. X is almost by itself. We just have to divide both sides by negative 2, and that'll get x completely by itself. and the right side over here on the, the other side anyway, ends up being positive 4. And that's that. Ooh, that's a little confusing, green stop sign. But that's it. So good luck on the quiz.